So now, if we go to results and update the results, two contour plots are automatically created. We have equivalent stress and displacement magnitude. We will first take a look at the deformation of the crank. And you can see that from this contour plot, the largest displacement is occurring at the end where the force was applied. And there's no displacement over here at our three fixed ends. And this agrees with what we would expect from the mathematical model. But if we wanted to take a look at the normal stress in the x direction, we'd go back to results and create a new contour plot. We'll rename it to sigma x and change the variable to stress and stress xx. Then evaluate. We see that there is what looks like very little variation in the z direction, so across the body of the crank. To further investigate though, we can create a cross-sectional view. We will do this by creating a new reference frame. So go back to results, go to auxiliary definitions, reference frames, and add reference frame. Then under origin and orientation, under origin, choose location based. And for the location, make sure the body selection filter is applied and choose the crank body. Now, using this newly created reference frame, we can create a plane. Under construction method, choose from reference frame. And under plane from reference frame definition, choose the reference frame we just created. And then for plane, choose YZ. Now we have our plane. So go back to results and add a new contour. And for the location, choose the plane we just created. And the variable should still be stress xx. And also change relative to the newly created reference frame. And then press evaluate. This cross-sectional view of the normal stress in the x direction shows us that there is very little variation in the z direction, which is what we would expect. And now, if we want to investigate the traction, we will create a new contour for the sigma y variation. So go back to results and add a new contour. This time, name it sigma y, and for the variable, choose stress YY and evaluate. We can see that the stress is very small in the middle and then increases as you move away on the x-axis. Next, we want to take a look at if equilibrium has been satisfied. To do this, we will create a force reaction. So back at results, under results, press add and choosing a force reaction. For the location, choose the faces of the fixed support. And then evaluate. We see that the y component is equal and opposite to the applied force, which is what we would expect, and the x and the z components are essentially zero.